Hi everybody, here we're going to go over the instructions for the Archimedes Principle lab. So let's take a look at the outline. So there's going to be three parts, part 1, part 2, and then part 3. In part 3 there's going to be a graph. So let's go ahead and take a look at part 1 and 2. They're going to be pretty similar. So for part 1, what you're going to do is when you load the computer simulation, you're going to set the mass and volume, mass to 100 grams and volume to 100 milliliters. And then, so you're going to record those values in over here in a table for in section 3. So you're going to record the initial mass and the initial mass of the bottle and the initial volume of the bottle. And for part 3, the volume of the bottle is going to remain constant. And after that, so once you've gotten the initial mass and you set the initial volume of the bottle, then you're going to start the experiment. And when you do, you'll see here that this mass is going to get submerged in water. And you're going to have two lines. So this first line here, so let me go ahead and repeat that. So the first line, that's going to be while the bottle is in air, that's going to be the weight of the bottle in air. And then the final one, that's going to read the weight of the bottle when it's submerged in water. So you're going to record those two weights over here. So the weight of the bottle in air and then the weight of the bottle submerged in water. And then after that, what you'll do is you'll repeat the experiment 4 more times to complete this table. So then you'll just reset and then increase. You're going to keep the volume constant for part 1. And for part 1, you're going to increase the mass to some new value. And then you repeat the experiment. So you'll get the weight of the bottle in air, and then also the weight of the bottle submerged in water. And it's to repeat this until you've completed this first table here for section 3. And once you've gotten that, then you'll go ahead and do your calculations. So for your calculations, you're going to calculate the buoyant force using two formulas. So if you go down over here, one formula, you're going to get the buoyant force by calculating the difference between the weight of the bottle in air and the weight of the bottle submerged in water, which means using the difference between these two values here. And that's going to give you buoyant force 1. Buoyant force 2, you're going to use this formula, which is going to be the density of water, the volume of the bottle that's submerged, and then gravity. And that's going to give you buoyant force 2. And then from there, you'll calculate the percent difference between those two buoyant forces. And similarly, you're going to do the same steps to get the buoyant forces for the other 4 trials. And then you'll complete part 1 by calculating the average percent difference for the 5 trials, and you're going to put that number over here. So that's going to be part 1. Part 2 is similar. For part 2, you're going to keep the mass constant, you're going to increase the volume. So you see the table looks pretty similar. So for part 2, you'll reset the experiment. And you'll again begin with the masses at 100 grams and the volume at 100 milliliters. And in this case, you're going to repeat the experiment. So the first trial should be similar. But for the other trials, what you're going to do is you're going to keep the mass constant and you're going to increase the volume. So you'll increase the volume to some new value and then repeat the experiment. So get the weight of the mass in air and then also the weight of the bottle in water. And then you just keep on repeating, keeping the part 2, keeping the volume constant, keeping the mass constant and increasing the volume, and then repeating the experiment. So it's probably best that you get some bigger volumes. But so what you'll do is it's pretty similar. In this case here, the mass should be constant, and you're going to be changing the volumes. Are going to change. And just like with the part 1, for each of these trials, you're going to record the weight of the bottle in air and the weight of the bottle submerged. And then once you've done those calculations, this table here is just like the one from section 1. So you're going to calculate the buoyant force FB1 and FB2, and then from there you're going to get the percent difference between FB1 and FB2, and you'll complete part 2 by calculating the average percent difference. Now let's go ahead and take a look at part 3. So for part three, you're gonna again restart the experiment, or reset the experiment, and begin with the masses with the initial 100 grams and 100 milliliters. And then for part three, what you're gonna calculate is once you've gotten the initial mass and volume, you're gonna calculate the product of the density of water and the mass in times the volume of the bottle. And then you'll start the experiment. In this case here, what you're going to record is FB1. So you'll record FB1, place it over here. And then for the second trial, what you're going to do is reset and increase the mass and the volume for both. And then repeat the experiment. And then record the mass of the bottle, the volume of the bottle, the product of density times volume. And in FB1, you'll get that from this data plot over here. And then you'll keep on. So then you'll go for, that's trial 2. So for trial 3, I'll show you one more time. You'll reset and increase both the mass and the volume. And then you reset and then you run the experiment. And then so from the experiment, what you're going to get is FB1. This the first one over here. You're going to record that in this section. And then rho V, that's going to be the product of the volume of the bottle multiplied by the density of water. And then you're going to complete this table here. And then once you've completed this table, you're going to make a plot of buoyant force, FB1 versus rho V. And once you've done that, you should get you'll insert that graph over here. And once you've done that, you should get a straight line. Again, it's going to be buoyant force on versus density times volume. So once you've made that graph, you should get a straight line. And the slope of that straight line, you're going to record that over here. And that should come out to be a familiar number. And then that's going to complete part 3 of the experiment.